let's talk about lipoprotein metabolism. So what is lipoprotein? Lipoprotein, as the name implies, it is lipid plus protein. So why there is a complex of lipid and protein in the blood? Because you know that lipid does not mixes with water, it does not mix with blood, it does not mix with plasma. So when you pour an oil or fat on water, what happens that it floats on top of that, so it does not mingles with water. That's why this lipid does not mix with blood, and to travel inside the blood in the circulation, what happens that it requires a coating of protein, that is called apolipoprotein. So the protein that coats these lipids, it is called apolipoprotein. So there are various apolipoproteins like ApoA, ApoB, ApoC, ApoE. These are apolipoproteins. So these coats lipids. So what are lipids? Lipids are triglycerides, lipids are cholesterol esters. So what is triglyceride? Triglyceride is fatty acids combined with glycerol. And what is cholesterol ester? It is fatty acids combined with cholesterol, is called cholesterol ester. You know that triglyceride, this has less density and more volume, whereas cholesterol ester has more density and less volume. And how much dense are these lipoproteins? So based on that density, they have classified these lipoproteins into very low density lipoprotein, intermediate density lipoprotein, low density lipoprotein, high density lipoproteins. So what is the density? Based on that, you can see as you go down, density of these lipoprotein particles increases. So density increases means as you go down, cholesterol ester increases and triglycerides decreases. So triglyceride decreases and cholesterol increases, ester increases as the density increases. So this is the basic of lipoproteins. So now let's talk from absorption. So let's suppose you eat your egg yolk. So egg yolk contains cholesterol ester, it contains triglycerides. So in the intestine, in the duodenum, it gets broken down into cholesterol, fatty acids. This triglycerides gets broken down into fatty acids plus glycerols, and this is with the help of bile salts, and that is called emulsification, and this gets absorbed in the lymphatics. So before absorption, you know that this should be packaged with apolipoprotein. So this gets packaged with ApoB48 and ApoA. So when the packaging of this lipid occurs with ApoB48, that is called chylomicron, and when the packaging of these lipids occur with ApoA, that is called HDL. So from the intestine, vast amount of chylomicrons are absorbed and some amounts of HDL is also formed, and this gets absorbed in the lymphatics. So now from the lymphatics, you know that this ultimately goes to the blood. These lymphatics dump in the superior vena cava, and from there this lipoprotein gets released in the blood. So you know what is chylomicron? Chylomicron contains large quantity of triglycerides, some less quantity of cholesterol esters. And what is HDL? HDL is large quantity of cholesterol esters and less quantity of triglycerides. So now these chylomicrons are traveling in the blood, and it goes near the muscles and ask muscle, hey muscle, do you need triglycerides? I have some triglycerides. So muscle says that, oh, I am exercising, so give me some triglycerides, I need for metabolism. So it gives some triglyceride to muscles. Now again it goes to the adipocytes, and adipocyte ask adipocyte, hey adipocyte, do you need these triglycerides? So adipocyte, so I am a bit of triglyceride, I am a storehouse of triglycerides, so why not give me triglyceride? So it gives triglyceride to adipose cells. Adipose cells, it gives triglyceride to muscles, and it also asks other cells, do you need triglycerides? I have triglycerides. So wherever is needed, it dumps those triglycerides there. So to dump those triglycerides, it needs an enzyme called lipoprotein lipase, and this is activated by ApoC2. This is another apolipoprotein. This activates lipoprotein lipase, and when lipoprotein lipase is activated, this gets broken down, and this triglycerides gets released, and it can dump into the adipose cells, it can dump into the muscles. So it has donated its triglycerides. Now there is less quantity of triglycerides because it has given some triglycerides to muscles, some to the adipose cells, some to other cells. Now there is less quantity of triglycerides, and there is more quantity of cholesterol ester, because no one has taken cholesterol ester. Everyone demanded, give me triglycerides. So it has given triglycerides. So now no one is taking cholesterol ester. So this is called chylomicron remnant. So this is remnant of chylomicron. So now it goes to the liver and asks liver that no one took my cholesterol ester, so what to do? The liver uptakes those triglycerides, whatever remaining triglycerides and cholesterol, and it breaks this down. Cholesterol ester is broken down into cholesterol fatty acids, triglycerides is broken down into glycerols and fatty acids, and liver thinks that, oh, I also don't need this much cholesterol and glycerol, what to do this? So let's again release back this into circulation, because when I store this, I will become fatty, and fat is not good. So it packages into VLDL, it packages into HDL, and it releases these molecules, apolipoproteins, again into circulations. So VLDL and HDL. So these HDL contains more cholesterol esters, VLDL contains more triglycerides. So this liver again releases these lipoproteins in the circulation. So VLDL again comes in the circulation and again goes to the muscle and asks muscle, hey muscle, do you need triglycerides? I have some triglycerides. Muscle says, oh no, I am resting, why do I need? I don't need triglycerides. So again it goes to the adipose cells and asks adipose cells, oh, do you need it? Triglycerides. So adipose cells, yes, I need it. I need to store it. I want to metabolize it, but I have depot house, so I will store it. So give me as much you give, I don't have any problem. So this triglycerides is given to adipocytes. Adipocytes and adipose cells stores these triglycerides, and it again goes to another adipose cells, and again it donates triglycerides, and then as much as it is donating triglycerides, what happens that this in the VLDL the triglyceride amount is decreasing. Triglyceride amount is decreasing, and there is cholesterol amount is still there is some cholesterol still present in this VLDL, because you know that in VLDL there is not only triglyceride but there is also cholesterol particle as well. There is more amount of triglycerides and less amount of cholesterol. So this, since there is cholesterol here, so this cholesterol needs to be esterified. So for esterification, it donates its cholesterol to HDL, because you know that this liver has also synthesized HDL, so HDL is also traveling in the blood. So it says to HDL, listen here, I have some cholesterol, so could you please esterify it? So if you esterify it, I can store into my interior part of the lipoprotein molecule, because you know that when there is cholesterol is facing towards the surface, and when it is facing towards surface and no cells need it, every cell says that, oh, I don't need it, I already have cell membrane, I don't need your cholesterol. So this VLDL says that, oh, no one is asking for cholesterol, so I need to package back inside it. So first of all I need to esterify it. So for esterification it ask HDL, could you please esterify it? So HDL say, okay, I will esterify it. So it gives, throws out cholesterol to HDL, and HDL what it does, that is cholesterol is combined with lecithin to form cholesterol ester. This is done by enzyme called lecithin cholesterol acyl transferase, and this is activated by apolipoprotein called ApoA. So this esterifies this cholesterol ester, and it again transfer back this cholesterol ester to this VLDL. This is through cholesterol ester transfer protein. So here this cholesterol again ester is again given to VLDL. So this VLDL now becomes IDL, intermediate density lipoprotein. So why? Because it is now containing cholesterol ester. Now it is containing cholesterol ester, and there is less amount of triglyceride because it has donated triglycerides, and now it is again circulating, and again there are some cholesterol, all cholesterol esters are not esterified. So it again asks HDL, oh, no one is taking cholesterol, so you please again esterify remaining cholesterol as well. So it again donates some cholesterol to HDL to esterify it, and after esterification it again gives back this cholesterol ester. So now it is containing cholesterol ester and little amount of triglycerides. So you can see as the cholesterol ester goes on accumulating, its density goes on increasing. So from intermediate density it becomes low density. Initially it was very low density, then it becomes intermediate density, and then it becomes low density. Now this LDL is circulating in the blood, and no one is taking up this whatever the material cholesterol ester is in there, in that LDL. Now it again goes back to the liver and ask liver, oh liver, no one is taking this molecule from me. So again it dumps back all those cholesterol, fatty acids, glycerol fatty acids in the liver, and the liver what it does with this, liver also says that I also don't need these things. So it again dumps back in the blood. So it again packages those into HDL, VLDL, and it again dumps back in the blood, and it again goes in the same and again same pathway, goes on. So you can see here HDL is synthesized by liver, and some amount was synthesized by enterocytes as well. So HDL is synthesized by liver and enterocyte. VLDL is synthesized by liver. Chylomicron was formed in intestine, and chylomicron was formed in intestine, and chylomicron remnant is a remnant particle that has formed in the circulation. Similarly, IDL, LDL, these are remnant particles that has formed in the circulation. So there is an interplay of these lipoproteins in the circulation. So you might have seen some cases where you might have seen there is high amount of triglycerides and there is low amount of HDL. So there is always inverse relation between HDL and triglycerides. If you have seen some reports, so you might have seen that if there is high HDL, there is low triglyceride. If there is high triglyceride, then there is low HDL. This is inverse relationship between HDL and triglycerides. So why does it occur?